All right, class, Algebra 2, Lesson 9.1, Simplifying Rational Expressions. Simplifying Rational Expressions. All right, so if you look at your notes there, first thing you want to do is to simplify. To simplify. All right, so how do you do it? What are we talking about here? And by the way, in case you hadn't caught it, whenever we say rational expressions, we are talking about your favorite fractions. All right, so we're dealing with fractions this chapter. So how do you simplify fractions? And we've done this before, and this is review, although we're going to apply it in a new way in this chapter. So let me say this. Way back in pre-algebra, I tried to teach you the correct way to reduce. And I tried to teach you that methodology, because if you learn how to reduce in pre-algebra, you can reduce anything. And so a lot of you learned that methodology. If you hadn't learned it yet, you got to learn it now, because it's the only way we're going to be able to factor these rational expressions. Or reduce, I'm sorry, these rational expressions. So how do you reduce a rational expression? First thing you have to do is factor the numerator and denominator. So if you remember way back to pre-algebra, I taught you guys when reducing fractions, factor the numerator, factor the denominator, and then what do you do after that? You divide out any common factors. That's the idea. That's how we do it. We'll start off with a simplistic example later on down the road when we get there, and continue on from there. But just a refresher here on the side, if we had something like 40/24, the idea is to factor the numerator. All right, that's a 4 times 10. What is this? A 4 times 6. All right, the common 4s divide out. And oh, by the way, a 10 is a 2 times 5. And a 6 is a 2 times 3. And I get out an additional 2. Solution 5/3, right? That's what I'm talking about in simplifying rational expressions. Factor the numerator, factor the denominator, divide out common factors. All right, so because we are factoring, we're going to need to review some aspects of factoring. Please do not forget the first law of factoring. How you can forget it, I do not know. I've mentioned it and mentioned it and mentioned it. We haven't even have this nice acrostic, FOCFF, and hopefully you remember what it stands for. You always have to look to factor out common factors first. Factor out common factors first. You've got to look. And again, why do students forget? Because not everything that you factor has common factors. However, when it does, you must get them out first. And so factor out common factors first. Very, very, very important. All right, let's do some more review of factoring. So here, this first example, we do have some common factors in this trinomial. So I'm looking at the blue numbers, an 8, a -6, and a 12, and the common factor of those is a 2. I'm going to leave a little space and put my parentheses, and I'm just going to deal with the numbers, all right? An 8 is a 2 times 4, so when I factor out that 2, I still have a 4, right? Again, this is the thought process. I'm taking out that common 2. A -6 is a -3 times 2, and so when I factor out that 2, that leaves the -3, and a +12 is a +2 times 6, and so when I factor out that 2, it leaves me the +6. All right, we can do the same thing with the variables, but there's only a common n in all of them. So I can factor out a common n. That leaves an n cubed left, right? N times n cubed is n to the fourth. In the second term, it leaves me an n, and I've gotten the n out, and that leaves me nothing in the third term. I can close my parentheses, and that is the factorization of that. I factored out common factors. Now we have a trinomial left, but that trinomial does not factor. All right, we'll talk about trinomials here in a moment. So first thing, factor out common factors. Remember, the factor must be common to all terms. If it is, then you can factor it out. If you ever wonder if you're correct, you can distribute. Just go ahead and do the distributed property, right back at it. You should get back to your original if you indeed factored correctly. So if you ever wonder, just distribute and see if you're right back where you were. All right, B. Look at the example there. Upon looking at it, you should recognize that it is a difference of, and I hope you're thinking, two squares. Difference of two squares. All right, how do we factor a difference of two squares? Well, first off, FOCFF. Factor out common factors first. There is a common 5 here. When I do, I get a 4y squared minus a 9z squared. All right. The binomial here is the difference of two squares, right? And it's that we are going to factor. All right, don't forget the common factor that you took out. It's still there. How do you factor a difference of two squares? Hopefully your brain is saying two parentheses. Then I hope your brain says plus in the middle of one, minus in the middle of the other. Then I hope your brain says square root of the first. 2y, 2y. Here, let me use my color, use black. Square root of the last. 3z, 3z. And there's the factoring of that difference of two squares. So I factor out common factors first. Then with the difference of two squares, two parentheses, plus in the middle of one, minus in the middle of the other. Square root of the first term goes first in each parentheses. Square root of the last term goes last in each parentheses. And every difference of two squares is exactly the same way. All right, and then the next methodology in factoring is factoring by trial and error. Most students do not like this method because it means you may have to try a few times. No, honestly, when you get good, you can get it on your first shot. Error on, is that what that says? E-R-R-O-R, much better. Looks about the same, doesn't it? All right. Okay, so we look at our trinomial here, and we're going to factor by trial and error. But again, anytime you factor, you are going to look to factor out common factors first. And there is a common 3 in every one of those numbers. That's going to leave me a 2a squared plus a minus 6. 2a squared plus a minus 6. All right, don't lose that factored out 3. We're going to need two parentheses now. All right, so let me use a little color here. I'm going to use my black. First off, the front terms have to multiply to 2a squared. So that means a 2a and an a. We know that. Use my green for the back. Now remember, the back terms have to multiply to a negative 6. So I got to either use, one of them's got to be negative and one's got to be positive. That's the only way I'm going to get to negative 6. However, the whole time I'm thinking this. When I multiply the outers and then add to it the multiplication of the inners, those better equal a positive 1a. This is what I'm thinking. So again, just to refresh your memory, if I were to put a 6 back here, 2 times 6 is 12. That leaves me 1 for the inside. Can I get a 12 and a 1 to equal 1? No way. There's no way that's going to be a 6. No way. I know it's not the case. So again, this is the thinking, right? This is what you're going through and thinking. So for me, I think, well, wait a minute. What if I put a 2 here? 2a times 2 is 4a. That leaves the 3 for in here. 4a and a 3a can get me a 1a, right? And in the red box, it's a positive 1a. So if I had positive 4a and a negative 3a, that will add up to 1a. There's the factorization. This is what you're thinking as you go through factor. Again, make sure, though, that you use two back terms that multiply to negative 6. And indeed, I did a negative 3 times a positive 2. Okay? Factoring by trial and error. All right, let's see how that fits into now our lesson of simplifying radicals. Let me go ahead and get rid of that so I have a little bit more room here. Okay, so here we have a monomial divided by a monomial. This is a straight fraction, and you're just simply going to reduce it. There's not a whole lot here. All right, I'm going to deal with the numbers first. A negative 32. How about a negative 8 times a 4? Isn't that a negative 32? And a 28, how about a 4 times 7? That's a 28. Now be neat. Sometimes you guys are sloppy and you lose stuff because you're sloppy. All right, so notice we've got a 4 in the top divided by the 4 in the bottom. They are gone. I'm left with a negative 8 on the top and the 7 on the bottom. They're going to stay right there. I'm going to move to my x variables. Okay, Algebra 2, I would just say there's x squared left in the top. But in case you're wondering how, an x to the fifth is an x cubed times an x squared. And now you can see how your x cubes divide out, and they're gone. Okay, now we got the y's left. All right, well, y to the fourth is a y times y cubed. And again, the y divided by the y's are gone. And just see where everything is. What's the top? Negative 8x squared. What's left in the bottom? 7y cubed. Again, you got to be neat or you're going to lose stuff. You got to be neat or you're going to miss stuff. So be careful, be careful, be careful there. Okay? All right, number 3 is quite a bit different. Though the bottom is a monomial right here, the top is a binomial. So first off, let me explain what you cannot do. You cannot think something like this. 6 is a 2 times 3. Let me divide this 3 and that 3. You cannot do that. That is not true. Again, if I give you an analogy, let me just show you something that will help you to understand. If I had 3 plus 9 divided by 6, that is a 12 divided by 6, and the answer is 2, right? Does this work? Now I end up with 9 divided by 2, and I get 4.5. So that it doesn't work. You can't do that. And if you remember, I'm trying to get you to understand that this term is tied together with that term by addition. That 3x squared minus 15x, it's a binomial. They are tied together by addition. So you cannot do that. So don't do it. 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 I got to catch up with all the stuff I just erased. Okay? So you say, Mr. Scarfy, what do you do? Ah, you factor. Factor the numerator, factor the denominator, and divide out common factors. Here's what I mean. Let's deal with the numbers first. Isn't there a common 3? Right? There's a common 3. And isn't there a common x? There is a common x. What does that leave you in the top? An x minus 5, right? 3x times the quantity x minus 5. Okay, that's what that has become. Now, when I do 2 times 3 for this 6, I can now take this 3 and divide it by that 3. You say, Mr. Scarfy, a minute ago you said I can't do that because it's tied together. What we have here are 3 things. Thing number 1 times thing number 2 times thing number 3. The 3 is multiplied times the x is multiplied times the x minus 5. That you can do. And those 3's you can divide out. I'll show it to you again in a minute with the numbers. So look, here's the same scenario, right? 3 plus 9 divided by 6. If you wanted to, you could factor out a 3 from this. Now you can divide out those 3's. What do you end up with? 4 divided by 2 is 2. Remember I told you that thing was 2? Okay, you see what we just did? That's a whole different story. It's a whole different story. And that does give students trouble, I must admit. Some students don't see the difference there, and that's the key to reducing fractions. You've got to see that difference. Okay, so we can divide out those 3's. 3 divided by 3 is 1, and they are gone. And I can do the same thing with these x's, right? An x cubed is an x times x squared. Now I can do x divided by x, and they are gone, and that's all I can do. Everything else stays. We're left with an x minus 5 in the top and a 2x squared in the bottom, and that's the solution. We've simplified it as far as we can simplify it. Okay? Come back and look at this again later. That's a key thing, and you can't make those mistakes there. And that's what I see students doing. They're going to want to divide that 3 and that 6 right away. You can't. All right, only factors. Let's do another one. Next page. All right, so you look at number 4. Again, we cannot do the 4 and the 10. You can't. The 4, it's a negative 4. It's tied into the x squared, and the negative 10 is tied into the 5x. You can't, you can't, you can't. However, I can factor the top. So when you look at the top, what does your brain say? You're looking right here. What does your brain say? I hope it says difference of 2 squares. And then I hope it says 2 parentheses, plus in the middle of the first, minus in the middle of the second. All right, remember how to finish it? Square root of the first, first. Square root of the last, last. Okay, that's what that is. You look at the bottom. I hope your brain says factor out common factors first. Let's take out a common 5. Leaves you an x minus 2. Now look what I can do. I can take this whole factor, the whole quantity x minus 2, with this whole quantity x minus 2. And because the whole thing is a factor, I can divide them out. All right, where do we end up? X plus 2 over 5. And that's the solution. That's the solution. All right, look at number 5. All right, so number 5, we got a lot here. All right, you look at the top, and we've got a common 3 we can get out, and we got a common a we can get out. Oops, I want that to be blue. So what's left? All right, a 2a squared minus a 3a minus 9. Okay, that's what that has become. Do not skip this step. It's very important. Now I can further factor the trinomial by trial and error. All right, remember, I need what multiplies to 2a squared, so I'm going to use a 2a and an a. I not only need what multiplies to a negative 9, but remember, I'm after this negative 3 in the middle. Well, I got 9 and 1 are my only choices, right? 9 and 1, 3 and 3. So if I put a 3 here, remember now I'm thinking about the outers multiplying. That's a 6a. That 3 goes there. That's a 3, a 6a minus. So what if I had a negative 6a and a positive 3a? Won't that give me a negative 3a in the middle? It will. And that is the factoring of that. All right, so the top is now 3a times the quantity 2a plus 3 times the quantity a minus 3. That's your top. Got to factor the bottom. Are there any common factors? Not with the numbers, but with the variables. I can factor out a common a squared. Leaves me 2a squared plus 11a plus 12. Let's go ahead now and factor the trinomial by trial and error. Again, please don't forget your a squared, the factor you factored out. All right. 2a squared, it's going to be a 2a and an a. What do I have to work with in the back? A positive 12. I can go 3 and 4, 2 and 6, 1 and 12. 3 and 4, 2 and 6, 1 and 12. And I'm always thinking, this is my first move always. The front times the back. Well, if I put a 12 in the back, that's a 24. I'm far away from 11. If I put a 6 in the back, that's a 12. But then I got to put a 2 in the middle, and a 12 and a 2 won't get me to an 11. However, if I put a 4 in the back, that's 8, and a 3 in the middle, 8 and 3 is 11, and everything's positive, right? Because you got a positive middle term and a positive last term, and there's the factoring of that. Okay, that has become that. Do we have any common factors? All right, one more in the front. Let's make my a squared and a times a. All right, this a, whoops, want it green there. This a on top with one of the a's on the bottom, gone, right? Divided out. The whole quantity, 2a plus 3, with the whole quantity, 2a plus 3, gone. All right, what's left? All right, here's what's left in the top, and I'm going to write it down here because I don't have room to the right, but you guys do. Okay, so 3 times the quantity a minus 3 is my top, and my bottom is a times the quantity a plus 4. Now let me pause for a second. Technically, this isn't the best way to leave your final answer. You should really multiply out the 3 in the a, but, listen now. For this chapter, factoring takes time. And so for us to enable us to give you enough problems and practice problems and also quiz and test problems, we're going to say leave your answer in factored form to save the time so that we can assess whether or not you know what to do with just the reducing. Okay, so leave it. Technically, it's not the final answer, but we're going to leave it that way for time's sake. Okay, leave it that way for time's sake. Whoa, I just moved everything. Let's go back. Okay, so leave it that way for time's sake. Okay, let's go to number 6. Number 6, I'm looking at the top. Are there any common factors to factor out? The answer is no, but I looked, right? Trial and error. Going to be an n and an n. Again, I got a negative 10. I got to end up with a 3. If I put a 5 here, and the 5s are positive, that's a positive 5 and a negative 2. Doesn't it give me a positive 3? It does. Again, if you can't do that in your head, you got to do it the long way. Uh-oh, look at the bottom. Do you remember the pattern for a difference of 2 cubes? Do you remember the pattern? Well, we learned it. Again, I can teach you. It's your responsibility to remember. You have to study and review to remember. I can teach you the stuff, but you got to remember. Okay, it's a binomial and then a trinomial. Do you remember what the sign is in the binomial? Okay, it's always the same. Do you remember what there's going to be 2 signs in the trinomial. The front sign of the trinomial is always going to be what? Opposite. And the back is always a positive. Okay? Do you remember what to put in the front of the binomial? It's the cube root of the front term. The cube root of n cubed is n. Do you know what to put in the back? It's the cube root of the back term. The cube root of 8 is 2. Okay? Do you remember what goes front? Oops, supposed to be red. Do you remember what goes in the front here? Whatever front term is, square it. So n squared. And we do the same for the back. The back is the back term squared. 2 squared is 4. And do you remember the middle? The middle is the front term times the back term. Don't worry about the signs. So 2 times n is 2n. All right, that's the factoring of that. Remember, we're reducing. I have an n minus 2 on the top and n minus 2 on the bottom. They divide out, and the rest is going to be the answer, n plus 5 over an n squared plus 2n plus 4, and that's your solution. Okay, one last one. I just need to show you a trick here. Something to look out for, something to be on lookout. If you look at them, it looks like there's nothing you can do. The top has a positive x and a negative 3, and the bottom has a positive 3 and a negative x. But here's a trick. Let me factor out a negative 1 out of the bottom. When I do, that positive 3 goes to negative 3, and that negative x goes to positive x. If you multiply it back out, you'll be right back at the beginning. Now, in addition, I'm going to rearranged commutative property, right? I can change the order. And now do you see how we can divide out the x minus 3's? So we end up with a 1 divided by -1, which final answer is -1. All right, reducing. Let me go back to the front page. What do you do to simplify rational expressions? You factor the numerator and the denominator. Divide out any common factors, right? Factor the numerator, denominator. Don't forget, whenever factoring, look to factor out common factors first. I reviewed a difference of two squares. I reviewed trial and error. And then again, the rest is simply factoring and dividing out common factors. All right, there you go. Hey, pay attention to this first lesson, because here's the reality. Everything we do this chapter, and we're going to add rational expressions. We're going to quote unquote subtract rational expressions. We're going to divide rational expressions. We're going to multiply rational expressions. And we are also going to solve rational equations. In all of that, the final step you want to do is reduce or simplify. So learn this first lesson, because it'll come into play in every other lesson in this chapter. All right, that's it. Have a great night.